Okay, we're going to solve some concept 1, roots and radicals problems here. We simplify number 1. We've got the square root of 21 times the square root of 3. The square root of 21 is the square root of 3 times the square root of 7, and we still have that square root of 3 on the end. Notice here that I have a root 3 times a root 3. Root 3 times root 3 is 3, and root 7 will not break out of the radical, won't simplify out of the radical. So 3 root 7. Let's look at number 2. I like to see this in parts. I see the number part here, the 4th root of 81. I see the x part, 4th root of x to the 12th. And I see the y part, the 4th root of y to the 16th. If I deal with all the parts independently here, I can make this work pretty easy. The 4th root of 81, well, that's just 3, because 3 times 3 times 3 times 3 is 81. The 4th root of 12, if I ask myself, how many times does 4 go into 12 evenly, the answer is 3. So this is x to the 3rd. And again, if I ask myself for y, how many times does 4 go into 16 evenly, the answer is 4. So this is y to the 4th. So my final answer here would be 3x to the 3rd, y to the 4th. Number 3 is a little more difficult, but same concept. I can look at the different chunks here. Got the cube root of 24. I got the cube root of a to the 10th, and I've got the cube root of b to the 12th. The cube root of 24, well, there isn't a perfect cube root of 24, but I know that 8 is a cube root and has a perfect cube, is a perfect cube, I should say, and is a factor of 24. So the cube root of 24 I could write as the cube root of 8 times the cube root of 3. The cube root of a to the 10th, again, I ask myself, how many times does 3 go into 10 evenly? The answer would be 3, so I get a to the 3rd. But I have 1 left over this time, and that 1 left over just stays inside. And then cube root of b to the 12th, that's b to the 4th, because 3 goes into 12 4 times evenly. So see, this is the same as 2 right here. The cube root of 8 is 2. So what do I have on the outside? I have a 2, a to the 3rd, a b to the 4th, and still inside the radical I have a 3 and an a. So there's my final answer for number 3. I'm going to simplify the fraction first. The cube root of 200 divided by the cube root of 5 is the cube root of 40. And then I know that the cube root of 40 is the same as the cube root of 8 times the cube root of 5. Why did I choose 8? Again, 8's a perfect cube. I know that its cube root is 2, so I'm going to get 2 cube root 5, my final answer on number 4. And that's it for concept 1. Concept 2 here, number 5, we're supposed to simplify. I notice that I have a 4th root of 10 to the x and another 4th root of 10 to the x. On the left I have 4 of them. On the right I have 3 of them. Therefore, if I add them together, I would have a total of 7 of those 4th roots of 10 to the x. So that's it for number 5. That's as simple as we can make that. We can turn that binomial into one term, into a monomial. Number 6, I see a negative 1 root 6. I see a positive 6 root 6. If I combine that, that's 5 root 6. I see a square root 36. I know that's 6. And I know negative 2 times 6 is negative 12. So I have negative 12 plus 5 root 6. And that's all there is to number 6. Number 7, we're asked to multiply the two binomials. Let's just go ahead and FOIL. 2 times negative 4 is negative 8. 2 times root 3 is 2 root 3. Negative root 3 times negative 4 is positive 4 root 3. And negative root 3 times positive root 3 is negative 3. Let's go ahead and combine some like terms here. Negative 8 and negative 3 is negative 11. And 2 root 3's plus 4 root 3's is 6 root 3's. That's it for number 7. Number 8, we're asked to square this binomial. And most people make the mistake of just squaring what they see. But what does it mean to square something? It means to multiply it by itself. So we actually need to write this as negative 2 minus root 6 times negative 2 minus root 6. That's what it means to square something. It means to multiply that something by itself. So let's go ahead and FOIL out this. Negative 2 times negative 2 is 4. Negative 2 times negative root 6 is positive 2 root 6. A negative root 6 times negative 2 is another positive 2 root 6. And finally, a negative times a negative is a positive. Root 6 times root 6 is 6. Combining like terms, 4 and 6 is 10. Plus, I have 2 root 6. I have another 2 root 6. That's a total of 4 root 6s. And we're simplified on number 8. And that's it. Number 9, we're asked to simplify. We have 11 to the 1/2 times 11 to the 1/2. There are so many ways to attack this. We could just add the exponents and get 11 to the 1, which is 11. Or we could realize that this is root 11 times root 11, which would be 11. So there are lots of different ways to get from the way they've presented the problem to the answer, 11. Number 27, that's a little bit more of a challenge. We've got basically the two parts here. I've got 27 to the negative 2/3. I've got 8 to the 6 to the negative 2/3. Let's deal with each part independently here. So let's deal with 27 to the negative 2/3. Oop, that's a 2 up there. Times a to the negative 6 to the negative 2/3. For just a second, let's forget about the negative, and let's just evaluate 27 to the 2/3. Well, first thing I need to do is find the cube root of 27. The cube root of 27 is 3. Take that answer, raise it to the second power. That gives me 9. What does the negative do to that? Well, of course, it inverts it. So that'll give me 1/9. So there's my 27 to the negative 2/3 is 1/9. The a to the negative 6 to the negative 2/3, I need to go ahead and, when I raise a power to a power, this is the only time I get to multiply powers. So let's go ahead and multiply the powers. A negative times a negative is a positive. 6 and 3 reduced to 2, and 2 times 2 is 4. So that would be a to the 4th. So this is times a to the 4th. If I want to, I can think of this as over 1, so I can multiply the fractions easily. If I multiply 1 times a to the 4th, I get a to the 4th. If I multiply 9 times 1, I get 9 in the denominator. So this simplifies to a to the 4th over 9. Number 11, we're going to write an exponential expression for 8x to the 4/3 in radical form. The common mistake here is to let the 4/3 do something to the 8. The 4/3 can't do anything to the 8 because it's not attached to the 8. There's a really big difference between what they gave us and what most people try to do with this. These do not mean the same thing. In the case on the right, the 4/3 works on the x and the 8. In the case on the left, the 4/3 just works on the x. So in our case here, these are not the same. In our case here, the 4/3 is only working on the x. So the 8, nothing will happen to it. We'll just leave it alone. For the x, though, it says that the x is inside of a cube root, and it's being raised to the 4th power. So there's our answer for number 11. Make sure you don't mess with the 8 unless the 4/3 actually needs to get to the 8 based on some parentheses or some power of its own. Like on number 27, or number 12, the 27 is actually being operated on by a 2/3. There's a 2/3 power right on the 27. So let's go ahead and work on 27. That's telling us to find the cube root of 27, which is 3, and then take the result and raise it to the second power, which would be 9. So that one's just done. And that's it for concept 3. All right, concept 4, we're going to solve the equation number 13. What I need to do here is I need to isolate this radical. I need to get that thing by itself, and then I'll go ahead and square both sides. So if I isolate that radical, the first thing I would do would be add 7 to both sides. So that gives me the radical x plus 10 is equal to 3. Now I want to get rid of the square root, so I'm going to square both sides. So x plus 10 would equal to 3 squared, or 9. So what did I do there? What I really did there was I just raised both sides to the second power. I squared both sides. And if you square a square root, they'll undo each other, and you just get left what's inside, which is really nice when that happens. Here I'm going to subtract 10 from both sides, and the result is x equals -1. Now because I've done this step right here, I've squared both sides, I have to make sure that I don't have an extraneous root here. I have to check that. So let's go just check this one mentally. I think we can do this one in our head. -1 plus 10 is 9. The root of that is 3. 3 minus 7 is -4. Therefore, this answer has to be right. It can't be wrong. Let's move on to number 14 here. I've got everything raised to the 2/5 power. I need to undo the 2/5 power, which means I need to raise this to a power that will force the 2/5 to be a 1. And whatever I do on the left, I have to do on the right. Well, that power that we're going to choose is 5/2. It's just the reciprocal, because 2/5 times 5/2, everything reduces out, and this whole thing becomes 1. So if I do it on the left, I have to do the same thing on the right. But realize, this is kind of sneaky. I just took a square root right here. I've got a 2 on the bottom. Took a square root right there, which forces me to introduce the positive and negative. Okay, because I have to have a positive or negative when I do a square root. It's just like when we're solving a simple problem like x squared equals 4. X could equal positive or negative 2. When I introduce the square root on both sides, I introduce the positive and negative on the non-variable side. So let's go ahead and work this through. I've got x minus 9. That all just goes to 1. Let's see. I've got the square root of 4, which is 2, raised to the 5th power, which is 32. So this is plus or minus 32. So x would equal 9 plus or minus 32. If I take 9 plus 32, I have 41. If I get 9 minus 32, I have negative 23. And I would need to check both of those back in the original problem, back up here. It turns out that when I do this radical power raising stuff to both sides, sometimes I'll get an answer that works in the equation down here, but not in the original. So I have to check for extraneous roots. And you'll find, I'm not going to take the time on the video to do this, but you'll find that both of those numbers check. So we have to keep them both. Okay, on to number 15 here. Solve the equation. We've already got the radical isolated, so we're just going to go ahead and square both sides. If we square 3x, we get 9x squared. Square the 3, square the x. If we square the radical side, we just get the binomial out of the radical, 8 minus 6x. So all we did there was we squared both sides of this equation. This looks quadratic, so let's go ahead and set it up in a quadratic form that we can deal with. So I've got 9x squared. I'm going to add the 6x over here and subtract the 8. That equals 0. I have to be able to factor that. What we've been working on in this class is the AC method, so let's go ahead and work through that. A times C is negative 72. B is 6. We have to try to come up with two numbers that multiply to make negative 72 but add up to 6. If you work with this a little bit, you'll find that 12 and negative 6 do that for you. 12 times 6 is 72, positive times negative is negative, and 12 plus negative 6 actually is 6. So from there, that's the AC part of the method. We'll go ahead and do the box now, AC box method. Set up our little box, 4 spots in our box, 3 terms here. The first term goes in the first box, last term goes in the last box. The negative or the positive 6 gets split up with these two numbers we found. So instead of writing a 6x anywhere, we actually write a 12x and a negative 6x. Again, if you combine those, you get our 6x back. Looking down this first column, I can take out a 3 and an x, just factoring those out. 3x times 3x would force a 9x squared. 3x times 4 would force a 12x. 3x times what would make negative 6x? Well, that has to be negative 2. And you notice the negative 2 times the 4 would give us that negative 8. So this actually factors to 3x plus 4 times 3x minus 2. And that equals 0 still. Therefore, x has to be 2/3 or negative 4/3. Let's make that 2/3 look a little better. If you try to check these, you'll find that the negative 4/3 will not work in the original equation. There's no way the radical can equal a negative value. So the only one that actually did check was 2/3, and I'll leave the check for you to verify. All right, let's turn our attention to number 16 here. Notice how we've got both sides raised to the 1/2 power. So really, we've just got the square root on both sides. Let's just go ahead and square both sides. The result there would be negative 7x plus 8 equals 2 minus 10x. And then we'll go ahead and try to get all the x's on one side. So I'll add 10x to both sides. That gives me 3x plus 8 is equal to 2. We'll subtract that 8. 3x is equal to negative 6 and divide by 3x is equal to negative 2. That answer actually checks. So I'll leave that for you to verify. and we're done. Okay, our last two problems on this exam. Composite functions, f of x is 5x plus 4, g of x is 2x minus 7. All they want us to do is find f plus g. Well, here's the f function and here's the g function. If we add them together, we'll have f of x plus g of x. So let's just go ahead and add those guys together. If I add them together, I can combine 5x and 2x, that's 7x. And I can combine 4 and negative 7, that's negative 3. And that's all we need to do for number 17 to find f of x plus g of x. Number 18, a little different animal here. We've got f of g of negative 2. I do not like that notation. I prefer the other notation. This means the same as f of g of negative 2. Notice I said the same thing when I read it, f of g of negative 2, whether I read each one. This one just seems to be clearer because you can see that the g function is actually inside the f function. So what this is telling me to do in either case is to find g of negative 2 first. Notice that's the thing all the way on the right here, or it's the thing on the inside here. So let's find g of negative 2 first. Well, what does that mean? That means to put a negative 2 in for x. So if we put a negative 2 in the g function, if we go to the g function, put a negative 2 in for x, I get negative 6 minus 7 is negative 13. So this whole chunk right here is the same as negative 13. So I need f of negative 13. What does it mean to find f of negative 13? It means go find the f function, find the x, and put a negative 13 in there. If there's more than one x, you put a negative 13 in for all of the x's. So I've got negative 4 times negative 13. What is that? 52. Minus 6 is 46. So there we go. F of g of negative 2 turns out to be 46.